Okay, hi and welcome. We're going to do some questions from a review 3B just so you get an idea of a few here. So I'm going to go quickly and we'll try to break this up. First one I'd like to do then is here. It asks us to graph this system of equations, not inequalities, because we're doing a little review in this section. So we're going to go ahead and graph these to solve for it. In this case, just to remind you what these are, this is your y-intercept, this is your slope. In this case, it's -1/1. Just kind of want to rewrite it out there. So let's go ahead and plot this really quickly. There's our 4. We're going to go down 1, right 1, and repeat. And we're going to get something that looks like a pretty good line here. Go ahead and draw our line in. So there is the first line. On the second one, you'll notice that isn't in the right form for that form of graphing, so we're going to go ahead and graph by intercepts, just to remind you. So with intercepts, I like to make a little table for an x-intercept. We're going to find the x-intercept first. We have 0 for the y-coordinate, and for the y-intercept, we're going to go ahead and have a 0 for the x-coordinate. So we're going to plug those in. We'll plug in 0 for y. That whole piece is 2 times 0 turns to 0, so we get a little equation to solve 2x equals 4 or x equals 2. So we find out that our first coordinate for that one is 2, 0. So there's our x-intercept. We'll do the same thing for the y. This time, though, we're going to plug 0 in for x. That whole thing turns to 0. We find out that it's pretty much the same thing. So y equals 2 or 0, 2 for that one. So if we put a 0, 2 in there, I know I didn't use a straight edge. I do apologize for that. If I can get this line to draw, what we should find, and these are terrible lines, is that they would be parallel. If I use a straight edge, I've done this previously. So with parallel lines, just to review, there is no solution for these. So this system has no solution for it. Okay, we jumped to the second page on our review, and in this section, we're going to go ahead and talk about how to solve for substitution. Recall that for substitution, we need to have some variable isolated, solve for, to start the substitution process, because we've got a system here, which means more than one equation. You can see 2, for example, number 3 here. I already have the answer. We'll work back to see how I got it. But what we need to have is what we've got. We've got y equals on both of those, so it's a great setup for that one. If you look at 4 really quickly, though, you'll notice that none of these variables are solved for. The closest one is this y. So if we did want to set this up for substitution, our first move before we substituted would be to move that -2x over. And then you'll notice, because none of this will be here anymore, then we'll have a y equals on the left side, and it'll be solved for. Once you have a variable solved for, you take what it's equal to and you plug it into wherever that y is on the other side. So y is equal to x minus 1. So this y here will become x minus 1 will be equal to 2x plus 7. Your goal is to have a single equation with just one variable in it. And we do. So let's go ahead and continue. I notice that we've got x's on both sides. I've got numbers on both sides. So I need to get them on the same side. So let's go ahead and subtract 7 to the left side. That turns into 0 is gone. And I'm going to move this x at the same time. Again, I'm using inverse operations here so that they turn to 0. So -7 and -1 make -8 equals 2x minus x, which is going to be a single x. So we find out that x is equal to -8. So now we've got half of our point, because a point is a solution for a system. This isn't an inequality, this is a line, right? Two linear functions. So we're going to plug that back in to wherever we see an x. So we'll plug it into that x there. So I'm going to rewrite it. Y equals -8 minus 1, or y equals -9. Our solution for this system of linear equations is then the point -8, -9. Okay, this next problem we're going to tackle is elimination. Again, we're solving a linear system. So for elimination, your goal is to have all of your variables lined up in columns, even your equal sign over your equal sign, and you need the same and opposite set of variables, so whatever that variable happens to be. So if you look at number 5 really quickly here, all of ours are set up into nice columns, equal signs over equal signs, x's over x's, and you'll notice that in this column my y's are the same and opposite. It's ready to go for elimination. However, if you look at number 6, it is in columns, which I'll have to tilt these a little bit just the way that they're written out, but those columns are correct even though they're curved. But you'll notice that none of our two variables, my x's or my y's, aren't set up to be opposite and the same. The closest one, though, is going to be this y. To get that to occur, what I'm going to do is I'm going to multiply everything by some value to make this the same as 15 and opposite. And well, it's already negative, so I'm going to multiply everything by 3. So all three terms are going to get multiplied by 3, so I'm going to rewrite the equation here. So 3 times 7 is 21x. 3 times negative 5, there's that negative 15y that I'm looking for, equals 3 times 17, which equals 51. I'm going to go ahead and rewrite the first equation because I like to have this nice and tidy when I go ahead and do this elimination portion. So there's the first equation rewritten. I'm ready to go ahead and eliminate. These turn to 0. That's my goal. Now I should only have one variable, which is x. That's going to be 19x, which is equal to 51 minus 32. So that should be 20 minus 1 is 19 is what we find out there. And I'm going to go ahead and divide by 19 then to finish this off. So x is equal to 1. Now that I've got that, I'm going to go ahead and plug it into one of the two equations. I'm going to plug it into that x there. So let's rewrite it with the new substituted value. So negative 2 times 1, because there's my 1, that's my x, plus my 15y equals negative 32. So I get negative 2 plus 15y is equal to negative 30, equal to negative 32. I'm going to go ahead and move this 2 over by inverse operation. So I'm going to add 2 to both sides. So I find out that 15y is equal to negative 30. And finally, I'm going to divide by 15 to turn that into 1. Y is left, so I get negative 2. So my coordinate point for this system, the solution for this system, is a single point of 1, negative 2. Okay, into this section, we're going to go ahead and move into inequalities. This you're going to find is the majority of the test. So these inequalities here ask us to solve and graph these. Again, the concept of this is exactly the same as we've done before with linear functions, except for we have to deal with the inequality, which means some form of shading, or in this case, when we're solving, because we will eventually graph, the first thing we need to pay attention to is if we divide or multiply by a negative number, we have to flip that sign. That's the only new rule that you have to pay attention to. And I picked number 11 because it has fractions, and sometimes we forget how to deal with those. And you're like, well, I've got 4/5 times v, so do I divide by 4/5? But recall with our fractions, instead of dividing by a fraction, we always multiply by its reciprocal to both sides, and that's how we deal with the fraction. So to review fractions and inequalities, we're getting both. That's great. Here's why this works. 5s divide into 1, 4s divide into 1, and then we get this awesomely easy multiplication on the right side, which is numerator to numerator, denominator to denominator. So v is left on the left, so v is less than, we didn't divide or multiply by a negative, so we did not need to apply this rule. So we find out that 7 times 5 is 35, and 15 times 4 is 40 and 60. Looks like these will reduce to 7/12. So we'll end up with v is less than or equal to 7/12. Okay, now it asks us to graph this. So if we were to graph it, we're going to make a quick number line. It's a single variable. Notice just a v. It doesn't have two variables like the other ones we were just doing. So when you graph these are generally be on a number line. We'll need to change that into some decimal. We know that it's less than 1, right? 7 divided by 12 is going to leave us a decimal. So this one, if we estimate a little bit here, we can even pull up the calculator if that makes you feel better. Sometimes I use it for that. 7 divided by 12 is not what I commonly do in my head. So we got 0.58, so just a little bit more than a half. We'll put 1 here. There's 0 for my marker, so here's half. We'll go a hair more. That's my 7/12. There's my line. It is a less than sign, which means it doesn't have the equal sign underneath, so it's going to be an open circle. So let's read this now, and I like to say that v is my solutions. So my solutions are less than 7/12, so meaning less than, I'm going to graph to the left this way. So that would be the graph of that one. All right, let's try one more down here. We'll look at 17. It's a little bit different. It still is a inequality. You can see the less than or equal to sign there. So let's go ahead and clean this up. I've got d's on both sides here. Actually, this is 11d. and 15D, and I've got numbers on both sides. Well, let's keep my D positive, so our first thing that we're going to do is go ahead and subtract the 11D off from the left, and we'll move it to the right. That'll keep my D's positive. So that means that we need to move the numbers to the other side, so I'm going to subtract 3 here from both sides. Those turn to 0, those turn to 0. So I get negative 9 and negative 3, which is going to give me negative 12, which is less than or equal to 15 minus 11, or 15D minus 11D, which should give me a 4D. Okay. Again, I subtracted, so I don't need to flip any signs yet because I didn't divide by any negatives. So I'm going to go ahead and divide by 4 to finish solving for D. So I'm going to divide that out. Negative 12 divided by 4 is 3. Again, there's a negative involved. However, we did not divide by a negative, so no sign flipping. So let's go ahead and graph this one. So we're going to make a quick number line. I got a 3, so here's my 0 for reference. I'll put 3 right here. It's an equal to sign. So at 3, at my boundary point, because that's what we like to call that, it will be an included circle or shaded in, meaning that that point is part of the solutions. And that 3 then, or my solutions, because that's what D is, that's my solutions. My solutions are greater than, because I hit the open side first, or equal to the 3. So my solutions then are going to be to the right for this one. So there's my solution set. Okay, in the next question, we're going to deal with compound inequalities because the last one we dealt with was a singular inequality. With the compound inequality, we have two types. We have an and the only thing that we need to pull from the and statement is that it should be an overlapping or a shared solution set. So it looks like a barbell, and if it's an or statement, it should be the exact opposite of that, if I can use the word opposite there, where there is no overlapping answers if they're exactly opposite of each other. So if we look to start, this is an or. Ors can be written as a single compound inequality, like an and can. And can be written like this, or it can be written as separately. An or must always be separate. This one looks elaborate, but it's really not that bad. We've got basically two problems that we're going to attempt to solve here. We're going to solve the left set here of the inequality and the right set here of the inequality, and treat it like two problems, and when we're done, when we graph it, we should end up with something that looks like this. That's the gist of it. So let's go ahead and attempt to do that. We want to get to this x here, which means that this whole term on top is divided by 3. So the first thing before I can get to my x is I need to get rid of this 3 that's in the divisor. So I'm going to multiply. Oops, actually I can't do that first. That was a close try, but notice there's an addition here. And if we do our reverse order of operations, and we're in the cleanup stage, but the reverse order of operations still holds true, which means that you have to always address addition and subtraction first, and then to address multiplication and division. Subtraction. There should be an S. Let me clean that up. Always deal with that. So let's move this 3 here out of here. So we're going to do that subtraction first. If we divide it by 3, what we may have forgot to do was divide this 3 by 3. And that would be where the mistake would generally happen. So I'm going to rewrite this. This 3 here is going to move to the other side. So I'm going to rewrite everything on the left. Negative 2x minus 3, that whole quantity divided by 3. Again, no sign flipping yet, is less than or equal to negative 7. Now we can multiply by our 3 to move this off of here. I don't need the parentheses for this. So I'm going to multiply by negative 3 to both sides. This 3 turns into a 1, leaving just 2x minus 3 is less than or equal to negative 21 now. Again, no sign flipping. Now we can go back and address this addition and subtraction because we've gotten inside those parentheses now. So I'm going to add 3 to both sides. I'm going to find out that 2x is less than negative 18. And now I'm going to divide by 2. So I find out that x is less than or equal to negative 9. There's 1/2 of our inequality. So let's attack the other half here. We'll notice that it's very similar in the setup as the last one. So first things we're going to do is move this 1 to the other side inversely, meaning we're going to add 1 to both sides. I'm going to sneak down here because I got more room. So 8x minus 2 stays in the top, all divided by 2. This is gone now, so we've got greater than or equal to 7 is where we're at. Now we can get rid of this 2 by multiplying both sides by 2. Those 2's turn into 1, leaving just 8x minus 2, greater than or equal to 14 at this point. Now we can again address our addition and subtraction first, so we're going to add 2 to both sides. And so we get 8x is greater than or equal to 16, and finally dividing by 8, we find out that x is greater than or equal to 2. So now we've got or, we're going to write in there. So here's our two boundary sets, right? Our solutions are less than or equal to -9, and our solutions are greater than or equal to 2. So if we graph that, let's make a number line here. Our boundary points, the points of concern, are -9 and 2. So if I do that, I'm going to make 0 here, I'll put 2 here, and I'll put 9 somewhere over here. So that looks about right. I didn't measure it out, but that looks good enough for us. These are both included. You'll notice there's an equal sign under both, so both boundary points will be outlined with a circle that's colored in. So because they're included, they are part of the solution set. So let's check this now. Our solutions are less than or equal to -9. So if they're less than or equal to -9, that means I'm graphing on this side, on the left side, because it's everything less than -9. And over here it says our solutions are greater than or equal to 2. So I'm graphing to the right. So there's our compound or inequality graphed out. Okay, and our next problem here on the next to last page on section 4 is that we're graphing a linear inequality. So we should see two variables here, which means that we're going to graph on a coordinate plane, and you can see by our examples here that's what we're going to do. So let's go ahead and graph these. We graph them the same way as we would graph a linear function. The only difference is we pay attention to the inequality and we shade when we're done. So this one's in standard form. So being in standard form, we like to graph with intercepts. So let's go ahead and attempt this. 0 for the y coordinate, 0 for the x coordinate here, or reverse that. So let's go ahead and find out what these two values are. We'll plug in the 0 for the y coordinate. So that whole piece turns to 0. Okay, with that being 0, I'm going to find out that I've got 2x is, and I'm going to change this to an equal sign because we're finding a coordinate point. We've got 2x equals -6 divided by 2 on both sides. I find out that x is equal to -3. So my x coordinate, or my x-intercept, is -3, 0. Let's go ahead and reverse this and do it for the y. So I plug in 0. This whole term turns to 0. So I get 3y is less, I'm going to use an equal sign again, is equal to -6. Let's divide by 3 on both sides. So y is equal to -2. So my y-intercept is -2. Let's plot those 2 points. I'm going to go to -3, 1, 2, 3. And I'm going to go to -2 down on my y-intercept. There's my 2 points. Again, I should use a straight edge. Maybe I will. I grab a line, and it should look pretty close to this. We'll use that. It's a little off, but there it is. Now let's do our shading for this. Or shading this point. We can't use the idea of below the line, right? That would be below. Y is less than the line, or y is greater than above the line, because it's not in that form. So we're going to use a test point. So my test point that I generally like to use, or that you should do as well, is 0, 0. So I'm going to use that point. I'm actually going to mark it down. I'm going to plug it into my equation here. So this whole thing turns to 0. This whole thing turns to 0. So 0 plus 0 is 0 and is less than -6. Is that true? Is 0 less than -6? No, that's false. So if it's false, I shade the opposite side that it's on. So in this case, I'm going to shade below the line. I do have to go back and address one thing here, which is the case that my line is not dashed. So I need to make this a dashed line. Why is it dashed? Because it doesn't have an equal sign there. So this is a dashed line. That will be my this is how I'll signify that that's a dashed, because I can't erase parts of that. Okay, in this question here, we're on the second to last page of the review. We're asked to write the linear function for this. So all we really have to do is write the boundary line here. We have to write the equation for that boundary line and then address that we're shaded above. So let's go ahead and do that. So we're going to attempt to write into slope-intercept form. It will be the easiest if we can. I'm going to look to see if I have a y-intercept that's clear, and I do. I'm going to look to see that my slope is easily identified, and it looks like it is. So let's go ahead and identify the slope. The slope looks like it's down 1, right 1, so -1 over 1, or -1 if you will. All right, and then my y-intercept is actually 4. So I've got everything I need, my slope, my y-intercept, so let's go ahead and write this. So I'm going to write y, leave the inequality spot open, -x, and +4. So all I did was plug those pieces in to where they went. Now I need to figure out my inequality. I'm shaded above, so I'm going to go ahead and say a greater than sign, right? So shaded above, and it's dashed, so I'm going to leave the inequality sign at the bottom off. Okay, in the next question on 29 here, I'm going to graph a system of inequalities. So we should have an overlap section that will be the solution set. So any points inside of this section on the solid line but not on the dash would be part of the solution. Nothing too different from graphing both boundary lines and then shading, finding the overlapped region. So the first one, though, you'll notice is a special case. In this special case, this is one of those horizontal or vertical lines. Anytime you see an X or just a Y and a number, that's what that means. So in this scenario, you have to remember this. If the Y is there, it means that you go through the Y axis at -3. So here's the Y-axis, here's -3. This means go through the Y-axis at -3. It is a less than sign, not a less than or equal to, so this will be a dashed line. So there's my dashed line. This says that the solutions are less than -3, so that means I'm shading below. So let's shade below. I'll do a very quick shading for these. All right, now let's graph our other line. I'll change my color. The other line then is a y-intercept of +1. It has a slope of 4/1, so up 4, 1, 2, 3, 4, right 1. Repeat, 1, 2, 3, 4, right 1. Repeat the other way, 1, 2, 3, 4, right 1. And we can draw a line from that. Again, I'm not using a straight edge. I do apologize. So now we got to adjust the shading. It is a solid line. It does have an equal sign underneath, so we're good there. It says the solutions are greater than, so we're going to shade above this line, which will be to the left in this case. So I'll grab a blue and I will shade this down. So our solution set we'll find is this green section in here. That will be our solution set. So this whole area, not including this boundary line because it's dashed, but this boundary line is included, and then everything in between those. There's our solution set. Okay, in this question here, we're finding that we're asked, oops, I'm trying to change my pen. We're finding that we're asked if this is part of the solution set. We could graph this and see if this points inside. That is a perfectly viable way to do it, but I'm going to show you how to do it algebraically. So algebraically means that we're going to take the fact that this is an x-coordinate and a y-coordinate. We're going to plug that in for both of these inequalities. We're going to plug it in here, and we're going to plug it in here. We're looking for true statements. If it's true for both, then it is a solution. Okay. If it's false, it's not a solution. So that's really what we're looking for to do here. So let's go ahead and plug in 2 and 3. So it'll, for the first equation, I'll write it up here. So 4, I'm going to use 2 for my x-coordinate, 2 minus 6 times 3, which is my y-coordinate, and that's got to be less than 0. So 4 times 2 is 8, -6 times -3 is -18. I don't need to go any farther because I know that's going to make a negative number, and I know that's less than 0, so we're true on the first one. On the second one, we're going to repeat the same process. So x is going to be 2, plus 2 for my y value is 3, and that has to be less than or equal to 3. Okay, so this is going to make 6 plus 2, so we know that that's 8. Is 8 less than or equal to 3? No, 8's larger than 3, so that's false. So it works for 1. It's in the first inequality solution set, but the second one is false, so it does not count for that one. So this is not, I repeat, not a solution for this system. Okay, so the last problem here that we're going to work with is a word problem that's a system of inequalities. So when we know that it's a system, we're going to be writing at least 2 situations. So we're attempting to look for 2 situations. If you read through this, you'll notice it talks a little bit about money. That should be one of your clues that we're going to be writing some type of a money situation. The other one then gives us a restriction of how many hours we can work. It says we can work at most 20 hours. So that's kind of an hours restriction or a total hours. I'll call it a total restriction. So those are the 2 things or the 2 situations we're attempting to write for this. So let's go ahead and write the total hours one. If you read the problem here, you've got 2 jobs, a dog walking problem, and the other one is a car washing problem. So we need to identify some variables here. So our D will represent the number of hours of dog walking, and C will represent the number of hours that we can work car washing. Okay, so now we've got 2 variables. When we know that we can work at most, which means 20 hours is included, but not any more than 20 hours. So let's write that one first because that'll be easier. It's our number. We'll do dog walking first because that's the first one that pops up here. So dog walking hours, the number of hours, plus car washing hours can be at most, but no larger. So this combination of hours can't be any, it can be including 20, but it can't be any larger than 20. So 20 has to be the upper side of that boundary. So there's our inequality for our number of hours, total hours. Now we need to write one for the total number of money. That tells us that we need to at least cover our weekly expenses, which is $92. So that's our upper boundary for our money. We need to spend at least $92. Okay, so we need to make at least 92. It can be greater than 92, but we need to make at least 92. So 92 is our lower end boundary. And then what we're going to get is per hour what we get for each job. So our dog walking is $7.50 or 7.5 for dog walking, plus whatever we make at the car wash, which is $6 per hour that we work at the car wash. So there's our two inequalities that we've written for this. Again, we've got a boundary on this one that says we can't work any more than 20 hours, so our line represents the lower half, or shaded below the line, of D plus C. And then this side, it says that we have to make at least or more than $92. So if you go over here to our graph, what we find is we find that this is 20 and 20. So this is our total number of hours. This is our boundary line created by that. You'll notice that we're in quadrant 1 because that's where reality takes. It doesn't say to graph it, but we might as well go ahead and take a look at it. So this would be our line for that. It would be a solid line because it's included. And this one says that we would shade below. So this line is actually shading below here. Okay, so the pink line is shading below. And if you look at our other one, our boundary line comes from 7.5D and 6D. That will be here, just to save you some time. So there's our two boundary points. It's in standard form. And this one, though, says that boundary line, we're going to shade above it. We need more than $92. So we're going to be graphing above that line. We probably could use a test point for both of those since they're in standard form, 0, 0. So if you did get confused there and you wanted to use a test point, that's fine as well. What you find is that the shaded region is in the middle. So any of these combination of hours that falls anywhere in here, right, above the blue line and below the red line, those hours will it'll keep you under $20 or 20 hours of work week, and it'll make you at least $92 or more for that situation. All right, so there's your review. If you have any other questions, post them in the community.